Let's talk about a few more examples involving this notion of domain. And specifically, let's take a look at the function j of x is equal to 3x divided by 5 minus 2x. So remember, one of the situations where we really have to worry about domain is if we have a denominator, because we have to make sure we can't get 0 in the denominator. Division by 0 is undefined. So if we run into the case where we do have a rational expression, what we're going to do is we're going to set whatever is in the denominator equal to 0 and then solve for that value. So I'm going to subtract 5 from both sides of the equation. We get negative 2x is equal to negative 5. Divide both sides by negative 2. And what this tells us is that at 5/2, we get 0 in the denominator. But that's a bad thing. Remember, we don't want to get 0 in the denominator. So in regards to this domain of this function, x can take on whatever value it wants to except for 5/2. So x can take on whatever real number it wants to except for 5/2. If we were to write this using interval notation, we have to show that x can take on whatever value it wants except for 5/2. So we're going to go from negative infinity to 5/2, and we're going to leave that open parenthesis over there, because remember, we can't equal it. And then we're going to go from 5/2 to positive infinity, again leaving that 5/2 open. So this is a number line with a hole at 5/2.